push buttons with the Arduino can be a little bit tricky. So the first thing we got to know is find out how they work. We'll look into that. And then the next thing we want to look at is, well, how do they work with the breadboard? And then the third thing to look at is, well, how do they work as an input device to the Arduino? And let me warn you, this can be just a little bit trickier than you might think, but I think you could handle it. So let's take a closer look at these little buttons. So I have two kinds of these little buttons. These little ones are the ones that came with the Arduino Student Kit, and they're similar to other Arduino starter kits. They're actually the same ones that are built into the Tinkercad, are pretty much the same size. And then I have some bigger ones that I bought at Micro Center store. I like these bigger ones, just they're more stable on the breadboard. They're more secure to click. They don't wobble. They're not so janky how they stick in the holes here. The little ones are just kind of wiggly, and the big ones are just more secure. But they basically work the same way. So let me look at this one. So basically what they've got is, if you look at the back of this, there's like 4 legs here. And if you look at, there's like 2 pairs of legs. You see the way that how to get that focus? The way that metal is bent. That actually is one continuous strip across to the other side, and same with this one. It's one strip across. So there's really 2 strips of metal across here, and when you push this button, sorry about that camera folk, when you push the button it clicks. There's a little bent metal disc inside that the button pushes down, and it contacts across. So when the button is pushed, actually all 4 of these legs are connected together. And when the button is not pushed, okay, this is connected to this, and this is connected to this, but there's no connection across any of the 2 legs that are side by side. So if I look at it in like how it's mounted on the breadboard. Oh, and one other difference between the two is, first off, I tend to like to mount the buttons as far as I can toward this edge, because I tend to have other components mounted here that are close to the Arduino. So I like to keep the buttons over here, like so my fingers don't get in the way of this other stuff. So when I push this little guy in here, it goes in like that, and it works. I can click it, but sometimes it's just a little bit wiggly. So they would go in like that, and I would tend to put them toward this side of the breadboard. That leaves me room to connect my wires from here over to the other side, kind of like I've done here in Tinkercad. I've put this button toward this side, and that gives me room here to connect. Like in this case, I've got a resistor that connects to the minus side, and then I've got a wire that connects here to the negative side of my LED, and then the plus side, the anode side, is connected to plus. So this is a simple little circuit that I'm only using the Arduino for 5-volt power. I'm not doing any logic in the Arduino, but you can see how I click that into the breadboard same as I would in the real thing. Now with these bigger buttons, they're actually too big to put completely on one side of the you know, that center divide in your breadboard. If you put them on the one side, let's see, it's kind of tricky. Now I find that having a pair of long nose pliers can be handy to kind of like straighten these pins back out when they get bent or bending your resistors. So that would connect into here. Let me connect these sides first. And I'd kind of have to bend, so it really doesn't fit well unless I connect it across like I've done here. So these bigger ones, I kind of have to straddle that divide. So I can't put them all the way across over to here, or there's no room to connect wires to then connect from that side to this side. So that's a little difference. I find they're nice and secure, but there's a little less room. So let's look at how this works here. Let's take our multimeter. I'm going to lose these little buttons. I had one here. It probably fell on the floor. And so if I set my meter to this, turn it all the way around past the resistance scales to this thing they call, that looks like a diode, called the continuity scale. Let me back this camera off a little bit. So on this scale, when I touch the probes together, it makes a little beep. I can barely hear that. I'm hoping your ears are better than mine. And then the scale goes to near 0 ohms. And the 1 kind of indicates, okay, there's no continuity. So if I look at any two contacts here that are on this same facing side, if I hold the probes against here and I push this button, notice how those two connect. Now I would get the same thing over on the other side of the button. So you can kind of connect wires on either side. You can see my scale there. When I push the button, it makes a contact. So it's easier to show you on these buttons than with the little buttons. But they basically work the same. If I were to touch these two contacts here, you see what I mean by it's kind of wonky. It's just harder all around. Let me take that out of my way here. So that's basically how it works. You got to understand how the wires are connected across, because if you turn this 90 degrees, they're not going to work. And I kind of showed you how they fit on the breadboard. With the big ones, I have to kind of straddle the center. With the little ones, I might tend to put them more over toward the edge, like I did here. All right, so let's look at this circuit in Tinkercad. Like I said, in this case, I'm only supplying 5 volts to the board. I'm not connecting to any of the pins other than the ground and the 5 volts. So the 5 volts I've got connected here to the plus. I call this the plus rail. So that any connection to any one of these holes will have 5 volts. And I took one from ground here and I show the wire going up around to this first pin. So any one of these pins in that row or that column will be connected to ground. So here's my little circuit. This shows how the button works. So when I push this button, it makes a contact between here and here. These two, it's called, in Tinkercad it calls it terminal 1A and terminal 2A, because they're trying to show that terminal 1A and terminal 1B are really always connected, and terminal 2A and 2B are still terminal 2. They're connected all the time. So when I push the button, there's a connection across this from 1 to 2. And you know, understand how the breadboard works now. This resistor then is connected to that terminal, and then the resistor kind of spans across the center. So there's another row of pins here, and that resistor connected to that wire, and the wire connects it to the negative rail. And on the other side of the button, I've got a wire connects over across the center divide, and then I've got my LED, my cathode connected to that one, and my anode to this side, then a wire to the plus side. So when I push the button, it completes the circuit, and the LED lights up. So that's how it works as a physical device. But let's look at how it works within Tinkercad. Within the Arduino, and we'll need to do just a little bit of coding. So let's call up another circuit here. I'm calling this one button high here, and you'll see later why I've called it button high. Okay, so what I've got here, I've got a similar circuit. I've got ground, I've got connected to this ground negative rail. The 5 volts pin I got connected to the plus, so I can either pick up 5 volts from here or ground from that column of pins. Now, so I've got my LED. Whoops, stop moving around here. LED connected from the ground side. It goes through our 220 ohm resistor to the cathode. I'm going to go on backwards here to then the anode connected to this red wire, which goes to pin 12. So I'm going to use this LED to kind of show how the button is working. And then over here, the button I've got connected. One side of the button is connected here to the plus, the 5 volt rail, and then the other side I got connected from here to here, and then from here to here across to the pin number 7. So when I push this button, the connection here is made between plus, so I'm applying the plus 5 volts to pin 7. Now let's look at the code here a little bit. Let me, if I can blow it up a little bigger so you can see it. How's that look? So let me just show you what I've done here in the code. So above the setup, at the very top, I've defined 2 integer variables. I've called it LED pin 1. No, I've called it pin 1 because I'm going to use maybe a second pin in the future. And remember, that's connected to pin. Let's see, I've got my, well, that's a different circuit. I better not show that one yet. So I've got the LED connected to pin 12, and I've got the button pin on pin number 7. So then within the setup part of the code that runs once, I define my pin modes. So let's define our LED pin 1 is going to be the output. So the output is I'm going to use it to turn the LED on or off. And now for the other pin mode for the button pin, remember what number is that? So the button pin is actually equal to number 7, and number 7 is the pin I've got it connected to. Let me just turn this meter off here so I can save my batteries. Don't need that for now. So I'm going to call that an input. So I'm taking an input from the button, and I'll use the LED as an output. Remember, each of these statements ends with a semicolon, just the way it works. Now I put this statement in here to kind of always put it here, serial.begin 9600. So that means if I want to put a diagnostic print to say what's going on with this code, what's the value here, what's the value here. I've already got that statement in there, so I've already got my serial port ready if I want to use it to print things for a diagnostic purpose. Alright, so in the loop, here's the thing we do. I've got an if statement. So in this if statement, we check digital read of the button pin. There's a function, digital read, and what's button pin equal to? Well, that's equal to 7. So we're looking at pin number 7, and if it is equal to the value they call high. Now, when you're making a comparison, you use two equal signs. If you're making an assignment, A equals B or A equals 5, or like we did up here, use 1 equal. So 1 equal sign makes an assignment. It assigns the value of 7 to button pin. But 2 equal signs says I'm making a comparison. Are the two things equal? So if what I read on the button pin equals the value of high, this whole thing together then is a logical truth statement. So it's either true or false. So if it's true, I'm going to do the stuff within these curly brackets here, which says digital write to LED pin 1. Now what's LED pin 1? Remember that's pin number 12. I'm going to set it to a value of high. So I'm going to apply 5 volts to that pin. And else, if that's not true, it's false, I'll do a digital write of LED pin 1 and set it to low. And then we just loop around and around. So let's start this simulation here. And we have a problem. Houston, we have a problem. So I click the button and nothing happens, and the light is already on. So I knew there was going to be this problem. I'm not fooled just yet. So what is the problem? Well, let me look at this closer here. When this button is not pushed, pin 7 is connected to this wire that goes nowhere to this, but to this wire. So pin 7 basically has an antenna sticking out in the air, picking up stray electrical signals. There could be static charges in the air. There could be electromagnetic radiation from electrical noise from the lights and from my computer monitor. There's always stray electrical signals floating around. So the value on this wire is quite undefined. It's what's called floating. So there's the problem. Now, let me show you what are we going to do about that. Well, let me show you first with an analogy of a screen door. Here's a screen door in the back of my house. What we have is a weak spring that tends to pull the door closed. So if I open the door and let it go, it closes. But it's a weak spring. I can push the door open. It doesn't stop me from opening the door. It just is it's just strong enough to pull the door closed, but it's nowhere near as strong as I am. I can push the door open. And so can you. So, but what if I took that spring off the door can just float. It'll flap in the wind. It might, if I say close the door, it might already be closed. If I say open the door, it might already be open. That's like what's happening in this circuit on the screen. It's the button says on, even though I didn't push the button yet. So it's randomly got a high enough voltage that it triggers the digital to say it's on. It's already at its high state, so as if the button is pushed. So the analogy here let me stop the simulation, in our Arduino world of a weak spring is a high resistance resistor. So let's bring out a resistor, and I'm going to give this a value of 10 K ohms. That's 10,000 ohms. So on our, if you have like this little resistor wheel, let's see, if I turn my desk and so on, 10,000 would be 10000. That's about, so that's a color band of brown, black, and then orange. So if you notice this resistor, when I set it to 10K, the color bands on it are brown, black, and orange. The same as we have here on our resistor wheel. So that's a 10,000 ohm resistor. And what I'm going to do, I'm going to turn that 90 degrees, and I'm going to connect it. So one end of it connects to this row of pins on the breadboard, which is connected to that side. It's actually also connected to pin number 7. Okay, now I'm going to take a wire and connect it from here to the negative side. So what that does is it just gives it, it's like a weak spring that pulls this side down toward the ground value. But when I push the button, the full 5 volts is applied here, and that resistor is so small it doesn't make any difference. So let's start our simulation here, and this better work. So if I push the button, now see, now the light goes on, I let go, the light is off. So you can see how that works. So, well, let me show you, I've got the same circuit. This one is just not, I was showing you how to connect it. So this is the very same circuit where I've got to pin 12, I've got this LED connected, and on pin 7, let me show you both of these. So I can show you on pin 7, I've got this connected to this side of the button, and the other side of the button is connected to the 5 volts. So when I press this button, I'm looking at the wrong one on the screen. Let me show you just the desk here. I was looking at the wrong place and surprised it didn't work. So when I push this button, it works. But now here's this resistor that's acting as what I call a pull down resistor. It's pulling this button when it's not connected. It's pulling that side down to the ground value. If I was to pull this resistor out, it might make a liar out of me now, but yeah, notice how flickery that is. It's wonky. You know, if I touch things or things near it, it's very unpredictable. It would not be usable. That's because this wire is just floating. It's acting as nothing but an antenna on pin number 7 when the button is not pressed. But when I put this back in here, connecting that, basically pin 7 now is connected to here, which is connected to the ground rail. So that's just enough of a resistor to kind of bleed off that extra static charge, and then it works very consistently. So that's one of the tricks of using buttons on the Arduino. You need to use this thing called a pull down resistor. Now let me show you, there's another way to do this. Let's go back to Tinkercad here. Let's change this circuit to make this resistor be a pull up resistor instead of pull down. So I'm just going to make a few simple changes. I'm going to take this wire and connect it to the negative side, and I'm going to take this and connect it to the plus. So now the resistor is applying 5 volts when the button is not pushed. And when I push the button, I'm basically grounding that pin. So let's start this simulation. Oh, I got to do something else first. I got to change my code because I've turned it around. So let's look at this code. So let's see what I need to change. Well, it's still pin 12 and pin 7. It's still going to be the LED's output, the button is the input. But here I got to do something different because now the button has the low value when it's actually pushed. So instead of high here, I'm going to change that to low. So if the button is low, I'll turn the light on. Otherwise, I'll turn the light off. Okay, so let's see how that works here in Tinkercad. So let's start the simulation. And it basically works the same, but I've kind of turned around the spring here. So the spring of my door now is pulling up. So this is called a pull-up resistor because it's this unconnected wire is now being pulled up to 5 volts until I push the button, and then it's completely grounded out with basically 0 ohms. And this being such a high resistance, it doesn't get in the way, it doesn't make any change at all. So I don't know if you catch how that works here. So what's the difference? Well, let me show you another thing I can do. There's a third way to do this. So let me delete this resistor and delete this wire and go back into the code. Let me zoom in on that. Oop, that's too big. So there's a different pin mode of the button pin. I've shown you so far can be an input or an output. There's another state where it says input underscore pullup. So the Arduino has the capability inside it to internally apply that little resistor. And I don't know why. It only can apply a pull-up resistor, not a pull-down resistor. So I think that's the only change I need to make here, is I've changed that to be input pull-up. It tells the Arduino, okay, internally connect a pull-up resistor. And we'll see how that works when I say start the simulation. And it works quite consistently. So I've kind of shown you three ways to do it. You can 2 ways with an external resistor, and it can either be a pull-up resistor or a pull-down resistor, or inside the code of Arduino, I can say make the pin mode be an input with the internal pull-up resistor applied. Now I tend to like that method myself because I don't need to apply one of these resistors to every button. So if I have some kind of a project where I have multiple buttons, you would have to have multiple of these resistors, and it makes the whole thing more complicated. So I like to use the internal pull-up resistor that's built into the Arduino. But let me show you, for example, another thing we do. Let me bring up another circuit I have here called. This is why I called it pin 1, because this one I have a pin 1 and a pin 2. Oops, let me show you the Tinkercad here. So okay, so in this circuit, we have now the same button, but I have two LEDs. So let's look at what I did in the code. So I added another integer. I have an LED pin 1, which is 12, and LED pin 2, which is 11. And then the pin mode for the input on the button, I call it input pullup. I'm using that pullup resistor that's built into the Arduino. And pin 1 and pin 2 here are both set to output. So those are both the outputs. And then inside the loop, I've got basically the same thing. I have an if statement that says, okay, if the button is low value, it means it's grounded out, then we're going to turn one pin to high, and then pin 2 we're going to set to low. Otherwise, if that statement is false, we're going to set pin 1 to low and pin 2 to high. So let's go back and let's turn the code off and start the simulation. And so when I push the button now, it turns number 1 on, turns number 2 off. And I didn't need to use that external resistor here because it's using the internal resistor. So this is kind of an example of why it's simpler to use the internal resistor using the input pull-up method when I define the pin mode. Plus it shows you an example of where we can use the logic in the Arduino to do multiple things when we push the button. The first circuit I showed, just the button directly connected to the LED. It wasn't using any logic in the LED in the Arduino, but this shows how we can use the logic to do multiple things, or maybe turn this device on and that device off in a similar way. Well, there's one other problem you can have with a button, is that it can mechanically bounce. So when you push the button, very quickly you wouldn't even see the light flicker, but it might bounce a few times. And it could be that in some kind of device you don't want that. For example, here's a device I have that uses push buttons. This is a digital caliper, and notice, for example, it has a button that converts from millimeters to inches. So I have there inch readings, and I push the button and it turns to millimeters. Well, I want that to read once. If the user pushed this and maybe it bounced and went twice, it would look like it went to inches and went back to millimeters again. So they have to be careful to stop that bouncing. Well, that's going to be a topic for another day. I just wanted to alert you to there's more trickiness to these buttons than you might think. But the basic thing is using these pull up or pull down resistors so we don't have that stray voltage floating on the wire. Alright, bye. See you next time.